Okay, Aubrey, this is lesson 2, compare and order numbers. So if you know how to figure out different decimals of fraction, like if you know how to find the decimal form of a fraction, then you can order pretty much any rational numbers. So let's take a look. Obviously, you know what these symbols mean. When you have A, that symbol, and B, this means A is less than B. And then if you have it reversed, this means A is greater than B. So that's how you would read those. A is less than B, A is greater than B, and then obviously that means equal to. To compare the size of numbers or order them on a number line, use the decimal expansion of each number. Numbers appear on a number line in increasing order from left to right. To compare an irrational number to another number, estimate its decimal value. Order the numbers from least to greatest and plot them on a number line. 16 fifths, pi, and 3.1. Convert the numbers to a decimal form. So we've got to figure out these. Now, when we use pi, we always just round to the nearest hundredth. So we've got 16 fifths, pi is 3.14. 3.14, is that right? And then we've got this last number, 3.1. So I've got to figure out what this is in decimal form. So the work is done for you over here, and it is 3.2. So 3.1 is already in decimal form. 22 sevenths is a common approximation for pi, which is 3.14. Compare the numbers 2 at a time. So 3.1 is equal to, so what they're doing here is they're placing the decimal in the hundredths place because this has a hundredths place, so you can compare accurately. So we have 3.20 compared to pi compared to 3.10. So then compare these two. 3.10 is less than 3.14, so 3.1 is less than pi. 3.2 is equal to 3.20, so 3.14 is less than 3.20, so pi is less than 3.2. And so what I like about this part right here is then they convert it back to the original numbers that you had to compare and then place them on the number line. So if you were to come across this on a standardized test or anything, this is what the expectation would be, is to place those numbers on the number line in the original form that they asked you to, even though you had to convert them all into decimal form to figure out the order from least to greatest. So here we have compare x and y using less than, greater than, or equal to. So, excuse me, y is to the left of x, which means it's less than x, because we go from left to right, least to greatest. So I would say y is less than x, or x is greater than y, is how I would say or write those two statements. All right, which symbol, less than, greater than, or equal to, makes this sentence true? Now, we haven't really talked a lot about square roots yet, which is in the next lesson. But really quickly, because you have to compare this with this, really quickly, square roots, we did talk about it in our last Zoom. And so perfect squares, the square root of 1 times 1 is 1. And then your perfect squares, well, 1 squared is 1. And then we've got 4 equals 2. And then 3 is 9. 4 is 16. 5 is 25. So this is like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Square root of 25 is 5, and so on. 36 is 6. 49 is 7. 64 is 8. 81 is 9. 100 is 10, and so on. So these are whole numbers. That's why they can be called, that's why these are perfect squares, because these are the whole numbers that it takes to get those. So the square root of 2 would fall somewhere around here, right? Square root of 2 would be right around here, between the square root of 1 and the square root of 4. So you know that the square root of 2 is going to be 1 point something, right? Because it's in between 1 and 2. So in order to figure that out, there's really no like perfect way to figure this out. You just kind of have to start guessing and checking. Well, the square root of 2 is closer to the square root of 1 than it is to the square root of 4. So you know the square root of 2 is going to be closer to 1 than it is to 2, right? So it's going to be, I would even say you could start with something less than 1.5. So what you would do is just start guessing and checking. So I'm going to start with 1.3 times 1.3 because you know it's like 1 squared. So 1.3 times 1.3 equals 1.69. Now that's pretty close to 2, but not quite there. So to take it even a step further, I'm going to do 1.35 times 1.35. 1.35 times 1.35 equals 1.8, getting a little closer. So now I'm going to try 1.37. 1.37. 1.37 times 1.37 equals, getting a little bit closer, but not quite there. Let's try 1.39. 1.39 times 1.39 equals, that's pretty close. If we tried 1.4 times 1.4, that's even closer. So let's try 1.41 times 1.41, that's even closer. 1.42 times 1.42. Okay, so what do we have here? 1.43 rounds to the nearest hundredth. Let's say 1.43. Estimate the value of the square root of 2 by finding which two whole numbers it's in between. We know the square root of 1 is 1. The square root of 4 is 2. So the square root of 2 is in between 1 and 2. They did 1.43. 1.43 times 1.43 equals 2.0449, which gets rounded to 2.04. So 1 and 40 or 1.43 squared is greater than 2. So since the square root of 2 is greater, is greater than 2, 1.43 is less than the square root of 2. There you go. So that was pretty tough work, but if you, and I did a lot of this work, which I probably didn't need to do, but that's all you kind of need to know is that because we have our perfect squares, if we have a square root of something that's not a perfect square, you kind of have to do this work to guess and check it. How do you compare a fraction to an irrational number? So you have to find the decimal forms of all of them. Decimal forms. And then for an irrational number, because it doesn't terminate or doesn't repeat, you can round to nearest hundredths place and then compare. If a number A is plotted on a number line, what is true about all the numbers to the left of A on a number line? What is true about all the numbers to the right? So for example, if we have this number line here and A is right here, what are true to all the numbers to the left? All the numbers to the left are less than A, and all the numbers to the right are greater than A. Compare each pair of numbers using less than, greater than, or equal to. So let's see. This one looks like it's pretty simple because you just can turn this into a decimal number, and then 2 written as a decimal number is 2. Same with this one. These, when you compare, I'll do that one with you. So now they're both negative, so they're both on the left side of the number line anyways, but behind 0. But 1 divided by 3, now look, so that's 0.3 repeated. So even though this goes, this terminates here, right? So if I were to continue to place numbers there, those would be zeros. So if you compare it to this one, which would repeat, this is actually greater than. Now, if there was a line over this, you could say they were equal to. But because there is no line, this number is actually stopping here. And if you were to compare these two numbers, you would place zeros back here, which would make this 1/3 actually not greater than. It's actually less than because it's negative. So this is actually closer to 0 than this one is, which would actually make this one greater than this one. This is, so that's tricky because they're negative. So the larger the negative number, the smaller the number actually is because it's farther away from 0. So that one was tricky. This one you can figure out because you can turn this into a decimal. And so let's take a look at this one because it's negatives again, which is tricky. So, but this one's actually pretty simple. So this is -3, and then the square root of 9 is 3. So to simplify this, it's -3, which makes these actually equal. And then the square root of 5 and 2. So let's look at our chart over here. The square root of 5 would fall right here. So we know it's gonna be in between 2 and 3. It's gonna be 2 point something. Now, the square root of 5 is closer to the square root of 4, so it's going to be less than like 2.5, and we're comparing it to 2. So it's greater than 2, but it's less than 3, so we would say the square root of 5 is greater than 2. And then if you look at this one, so we know the square root of 5 is going to be 2 point something, right? And it's going to be less than 2.5. And then if we simplify this, 5 divided by 2, that's 2.5. So we know that the square root of 5 is going to be less than 2.5. And we know that this right here is 2.5. So you're kind of just estimating this without finding the exact answer to the square root of 5. You know it's going to be, the square root of 5 is less than 5 halves. And really, if you did want to prove that, there is this square root button on a calculator that you can figure out. So 5 square root, and it's 2.2, and it goes on and on and on. All right, so let's do number 10, also the square root of 7. So if we look at our chart, the square root of 7, again, falls like right here. So we know it's going to be 2 point something, right? Because it falls between 2 and 3. 2 point something. Now we know it's going to be greater than 2.5 because it's closer to the 9 than it is the 4, and we're comparing that to 3. So it's going to be greater than 2 but less than 3 because the square root of 9 is 3, and we're looking for the square root of 7. So just by estimating, we know that it looks like this. And to prove that, 7 square root is 2.6, and so on. So you know 2.6 is less than 2.3. All right, so I hope that helps kind of finding the estimated square roots of numbers and figuring that out. And then you're going to go ahead and compare these on the number line. Now remember, when you're working with negatives, the larger the negative, the farther it is away from 0. So I'm going to go ahead and do 12 for you. Let's put these into decimals. 3 divided by 4 equals, so negative 3/4 is equivalent to negative 0.75. And then 7/9, negative 7/9, and I'm going to round that, equals negative 0.78. Okay, so this is going to be closer to 0 than this, right? This is a larger, 0.78 is a larger number, but it's a negative, so it's farther away from the 0. And so this is broken up into tenths. So this is negative 1/10, negative 2/10, negative 3/10, 4, 5, 6, 7. So I wish they would have made them a little bit farther apart, but 7.5 would be like right here. So this is negative 3/4, and then negative 7/9 would be like right there. That one was tough. Okay, and then go ahead and give these a shot and see how you do. And let me know if you've got any questions over email or Google Chat.